question 9, class 10, chapter 2, polynomials. Now over here, we have again to find the zeros of the polynomials by factorization method, and we need to verify the relations between the zeros and the coefficients of the polynomials. Now, to find the zeros, we'll equate it to 0. Go and give it a try for sure. And once you're ready with the solution, you can refer to this video again. And don't forget to share, like and subscribe our video if you like it. Let's start and go ahead with the solution which we have. Now over here, let's take the LCM first because we have 3 by 2 with us. So after taking an LCM, we'll be getting 2y square plus 3 root 5y minus 10 equals to 0. Now over here, we need to split this term and we need a number which is 10 times 2, which is 20. So we will be going ahead with the factors of this 20, or we will be breaking this 20 in different factors, prime factors. So what do we get? 2 times 2 times 5. So we have 2 times 2 times 5, but since I need square root 5, so we can go ahead with that 2 times root 5 times root 5. Now out of these two, we can try it out and see what all combinations do we have to make 3 root 5. Now, if I'll just talk about 2 into 2, 4 root 5 and root 5 alone, can we get after subtracting or adding 3 root 5? Can we? Yes, we can. How come? If we have 4 root 5 and we have root 5, if we'll subtract both of them, I'll be getting 3 root 5. But since I need minus 20 over here, so among these two, one of the 0 or one of the term will be negative. Now we need plus 3 root 5 over here, so for sure, since 4 root 5 is greater than root 5, so we'll be getting minus root 5 and 4 root 5 as our breaking terms. So we'll write it down as 2y square plus 4 root 5y minus root 5y minus 10, which is equals to 0. Root 5 common as well to make it as y plus 2 root 5, as 2 root 5 into root 5 will be 10, which we'll be getting over here. We need to keep that in mind that we need these two terms exactly same. So that out of these four, we can take these common again. So we'll be taking y plus 2 root 5 common and 2y minus root 5 as another product. So out of it, what we can do is 1 is minus 2 root 5 and second 0 is root 5 by 2. Now let's try and verify things as we need to verify it as well. So if I'm talking about sum of the zeros, by adding these two, 2 root 5 plus root 5 by 2, taking LCM, we'll be getting minus 4 root 5 plus root 5 by 2, which is minus 3 root 5 by 2. And sum of the zeros will be minus b upon a. Now I know over here a is 2, b is 3 root 5 and c is minus 10. So minus b upon a will be minus of 3 root 5 upon 2. Now if you can see that, so we can understand that left hand side will be equals to right hand side, hence verified. Now how about product of the roots or product of the zeros? So that will be c upon a. So if I'll talk about left hand side, that means we are multiplying these two. So we'll be getting minus 2 root 5 into root 5 upon 2. So we can cancel this out. We are left with only minus 5. And let's talk about c upon a. C is minus 10, a is 2, which will be minus 5. If we can see these two, we understood that left hand side is equals to right hand side, hence verified. So we have verified. So in this question, what we did actually is, we've just taken the LCM and we did it the same exactly we did question 4, 7 and 9. So it's exactly the same which we did, but we need to go ahead with the first three steps which we have. I hope you understand that. Take care. See you in the next video in the next question. Thank you.